To paste the rules code in one cell and then the rules in another cell, we'll get the output like this. You can see the rule which is created from the tree. From the tree only the rules will be created and then those rules are used for prediction. So it's a rule-based prediction system that is used by decision tree. On this data, run the logistic regression. We have not done the logistic regression. Run logistic regression. So anybody ran logistic regression on this data? I'm talking about logistic regression, not in decision tree. You will take the variables which are found important in decision tree and build a logistic regression model. That will have a better performance compared to the full variable model. Did you build the full variable model first? So what was the accuracy?
On variable importance, it is showing 79.
Yeah, it is an improvement, right? Logistic regression, it is important, right? It is showing a better performance compared to the old model. This is not R square, this is accuracy. How can you say this is R? This is accuracy, no? Yes, you have to do that only. 80.37, 80.26, stable model, logistic regression. You have taken how many variables? Only 4 variables you have taken, huh? Because without that only the model is giving you good performance, no? Why do you need to do variable selection again? This is base model itself is giving you a good performance with stable things. So why do you need to do variable selection again? If it is not giving you, if it is underfitting, then you go and do variable selection. When the whole model is giving you full things with also cross-validation giving you a stable model, what is the need for a variable selection? It should be done when the model underfits. That is the problem with data decision tree, na? We have to, that's why we have reduced the max depth. That's why we came up with the max depth thing. Max depth will help you to bring the cross-validation score and the actual model score closer to one another. Otherwise, by default, it will overfit. To reduce the overfitting, you do a max depth. And then you will cross-validation and max depth score should be around, difference should be around 5% or less than 10%. Decision tree model. Decision tree model will be the better one, no? Compared to the logistic regression model. First logistic regression, then decision tree, then ensemble models, then specific models like support vector machines and all, and then finally neural networks. Nothing to be done in decision tree, not on dependent variable, not on independent variables. If you want to do, you can do it, but it will not affect the model. They are not important. They are important only when you are looking at what you call this is the one you have to look at. See, you have to start reading the documentation. So unweighted mean per label and support weighted mean per label. They are different metrics which are not considered in machine learning. They are different metrics we don't consider. We only consider the accuracy, the plain accuracy. You will also look at because there is imbalance in this data. There is an imbalance in data. Very few truths are there, many number of false are there. So we have imbalance in this data. Now, if I do the same thing so decision tree has an overall accuracy of 0.83. Logistic regression has an overall accuracy of 80%. Precision F1 and recall score of logistic prediction of 0 and 1 classes is less compared to the precision recall of F1 score of. So you only look at the metrics, which is average, precision, recall and sensitivity F1 score. TP by TP plus FP. It will separate the values also. The confusion matrix which we are doing is for overall zeros and ones. It will build a completely different matrix for each observation. Zeros within the class. One class, how many are predicted as zero, how many are predicted as 1. It will do a sub-matrix also, classification report. I am doing an overall matrix of 2 by 2 matrix. There you will get overall within the class confusion matrices are also built in the backend in classification report. So for class 1, one confusion matrix will be built. For class 0, one confusion matrix will be built. Separate confusion matrix will be built for each class. See, precision, recall, F1 score is related to imbalanced data only. Okay. It is not related to your false positives and false negatives. False negatives you will look into when your accuracy is very bad. Or when your accuracy is also not good, when your false negatives are higher, how we will deal with it. Now, in this case, if you look at the confusion matrix of decision tree, 1 is bad, 0 is positive, 1 is negative, right? So this is true positive, false negative, right? This is false positive, this is true negative. So here, look at them, they are very less. False negatives on the decision tree are very less, which is good. Okay, false positives are also there, which is affecting your ones. They are not affecting they are affecting the ones. This problem is because of the imbalanced data. Less number of false true are there, more number of false are there. If you look at our data, 5,000 false are there, zeros are there, 1869 only are true are there. If they are closer to one another, we will not have this problem. See, false negatives are higher compared to decision tree. False positives also. The false negatives are not that high. This can be corrected by balancing the data. By balancing the data, we can correct these problems. Balancing the data means either you undersample the 5,000 observations to a lower level, or you oversample the 1,000 observations to 5,000 observations. Undersampling and oversampling can be done, and then we can do that. False negative and false positive corrections. But you will have false negatives and false positives in your data. No model will predict 100%. No model will predict 100% accurately. It will have false negatives and it will have false positives. We need to go with minimum amount of false negatives. We can only minimize them to an extent. We can't make them. We can only reduce them. And in some cases, false negatives and false positives are not that risky. It depends on your business problem. In business problem, false negatives and false positives are that risky. It depends on the business problem. If you are looking at loan approval rate, false negatives are risky. False negatives are risky. But if you are looking at default, whether the customer will default or not, you can take them lightly, because that may happen or that may not. Defaulting on the loan or a credit card payment can happen or cannot happen in false negatives and false positive. That risk you can take a chance. But approving a loan to a false negative or a false positive customer is little bit. So one thing is, you can't eliminate false negatives and false positives. You can only minimize them to an acceptable level. It depends on the business problem, whether the false negatives and false positives are risky or not. So that is also you have to take into consideration. That's what now you have to look at, see, where is the problem here? The reason why false negatives and false positives are coming is this. For the majority class, you have 85-89 prediction percentage of accuracy. For minority class, it's a very less underfitting. The range is 0.70. All the metrics must be above 0.70. They're underfitting. Even in case of decision tree also, they are underfitting. Except for one precision, rest of all are underfitting. 0.70 is the minimum for all metrics in classification report. So this is the problem with imbalanced data. Now, if you look at these tree model, which I have done earlier on this one, you can see how the what you call RMSE reduced on a regression model without doing anything to what you call logarithmic transformation, or whereas in case of logistic regression, we have to do logarithmic transformation, then we have to do all those things. But in decision tree, I didn't do anything. I just gave Y and I got an RMSE which is less than my linear regression model. Very less RMSE compared to the basic linear regression model. So tree-based models will have a better performance compared to the baseline models. And the amount of pre-processing you do is also limited or minimal, even if you don't do any pre-processing, because they don't have any assumptions. They don't have any assumptions. Whereas linear regression and logistic regression has assumptions which need to be met. If one assumption is not met, then the model will underperform or model will fail. Whereas we don't have that problem in decision tree. We don't need to do any sort of scaling or transformations, nothing. You give the data to it, it will work. And even though imbalanced data is also there, it has a better performance than logistic regression. In the other case, see here, telecom churn. See, these metrics are better for this model, right? Compared to this model. Even in case of imbalanced data also, decision tree performs better than logistic regression. Tree-based models have a better performance than the baseline models. And the tree-based models work with any type of, whereas baseline models, you have to go through assumptions. You have to make sure that assumptions are met, assumptions are validated, then only they will. But what happens is, sometimes we have to go with baseline model only. If the client doesn't want to go with high-end models, he says, I want only logistic regression model, then we have to go with logistic regression model only. Sometimes the clients will specify based on their strategy and all, that I want a specific model. So we have to fit the data to that model. Do appropriate changes or transformations to the data and advise him how we can bring that data to fit that particular model. This happens with logistic regression. Sometimes client doesn't want to change the model. They are using logistic regression. They want to go with logistic regression only. Then we may suggest him model like decision tree or neural network, but he still will insist on logistic regression. And if the model is not performing to that expectation, so we have to do the necessary changes to the data and then bring that model to It happened with one of the client with one of the student here. They were already using logistic regression in SAS. He suggested decision tree model, but they said, no, we will stick to the logistic regression model, and they implemented in Python Spark because it's a very large data. Despite decision tree has a better performance of 5%, they said, no, we will go with only logistic regression model, which is their existing model, which they have been using. So that is what is happening. Sometimes they don't want to invest on the additional computing power. Sometimes they don't want to change the model, which is already working them well. So we have to stick to that particular model only. So tree-based models are better compared to the baseline models. Any other doubts? 17 December, 15 December. Yeah, this is not that bad. That is for seeing the rules. To show you the rules, that code we have used. That rules thing is also being implemented in Python. Maybe in the next version of sklearn, you'll get that by default in Python itself. It is in experimental phase. For now, we will use that is in the test phase. If you want to see the rules, generally what we used to do is we used to show the rules in R. R software will give you the rules, or SAS will give you the rules. Statistical software will give you the rules. So Python now in the somebody developed that rules code and they have submitted for evaluation. So it is under the testing and the experimental thing. Maybe next version of sklearn we will get that rules also in our, like how we get plot underscore tree, we may also get plot underscore rules. So then it will be added, but now it is in experimental phase. Now rules are required when your client says, I want the rules to check whether the predictions are being done correctly or not. Particularly in banking industry, we have to go through the rule one by one. Client wants to see the rules. What are the rules that are being used for approving or disapproving loans? That happens when the customer starts complaining, saying that I am not getting loan when I am eligible for loan. That time you have to give the rules which are being used for prediction. If you look at the application-based loans, which are being there on Play Store and all those things, a lot of people say, I have filled, I didn't get the loan. That means there is some problem with the algorithm and the rules. They also use the rule-based system. So they have to look at the rules, which rule is violating what rules. So sometimes what happens is one rule violates the other rule. Contradiction happens. To avoid that, we need to look at the rules. So what we will do is hundreds and hundreds of rules. Then what we do is we will prune the tree. Prune the tree means reduce it to a lower level. Now pruning again is a statistical process. When we discuss in R, that time I will talk about pruning. In Python, we can't prune the tree. So there we can do the rule reduction. Reducing the number of rules also is possible. So you will limit the rules to a lower level so that the applications work faster. Trees will generate a lot of rules, but you want to have specific set of rules, only limited rules to be there, then you have to prune the tree or reduce the number of rules. So rules are also a problem sometimes. Too many rules is also a problem. So logistic regression, we got AOC of 0.85, 0.89 for decision tree, ROC curve, area under the receiver's operating curve. So if you are looking at this AOC score and all formulas, the complex formula, let's not go with it. So AOC curve also, decision tree has a better performance. Primary metric is accuracy. First of all, you always look at accuracy. If it is imbalanced data, then you have to look at precision, recall, and F1 score. All three you have to look at. All of them for the minority class should be greater than 0.70 or should be closer to the majority class. Area under the curve is also a metric which is used for model. Sometimes if you have very close accuracies, if you can't make a decision to say which model is doing well or not, then you will go with AOC. So all the metrics are required. Based on a combination of all the metrics, you'll compare the model and come up with the best fit model. So we can't simply judge a model on single metric. It has to be done on multiple metrics. All right, we'll continue. So machine learning, supervised learning, tree-based models, multi-tree models, also called as ensemble methods. Within ensemble methods, the most popular, the first method is bagging, aggregating. Full form of bagging is bootstrap aggregating, and the popular algorithm is random forest. Supervised learning, tree-based models, multi-tree models. In decision tree, only one tree is built. In multi-trees, you can specify as many trees you want. Hundreds and thousands of trees you can specify. Multi-tree models, also called as ensemble methods. Within ensemble methods, the first method is bagging. The full form of bagging is bootstrap aggregating. The popular algorithm is random forest. Random refers to the sampling method it uses, and forest refers to multiple trees. Random refers to the sampling method and forest refers to multiple trees, random forest. Two aspects of this algorithm is random sampling and multiple tree building. Now, this is a very complex algorithm. The number of trees to be built, number of trees to be, let us say n underscore estimators is equal to, so you're asking it to build 1000 decision trees. You are specifying the algorithm to build 1000 decision trees. Is the most critical task. Samples of data randomly 65% of the and square root of number of variables. Step 2, it starts creating samples. 1000 samples it has to create. How? 65% of randomly selected rows and square root of number of variables per. Let us say you have 10,000 observations and 16 variables. So sample 1 will be randomly selected 6,500 rows and square root of 16, 4 variables. Randomly selected 4 variables. Sample 2, again a new sample 2 will be created, again selecting randomly 65% of the rows, square root of 4 randomly selected. This process it continues till it creates 1000 samples of data. The sampling method being random also uses aggregating method. Bootstrap aggregating, observations will appear in multiple samples. Observations will appear in multiple bootstrap aggregating or bootstrap sampling method is where observations will appear in multiple samples. That also called as data with replacement method. The other name of bootstrapping is data with replacement method. So this is our original data. You can see here, this is our original data. Sample 1 has x1, x3, x4 and dependent variable, and then A1, C1, D1, A2, C2, D2 randomly selected rows. In sample 2, x2, x3, x4. So x3, x4 are repeating. Similarly, if you see here, observations are not repeating, but here they are repeating, right? Observations also will repeat, variables also will repeat. This process we call it as bootstrapping. Bootstrapping is creating subsamples of data, as many as we specify from the original data by random selection of rows and random selection of columns. How many rows? 65% of the rows. How many variables? Square root of number of variables. So each sample will have only limited variables. It will not have all this sampling method we call it as bootstrapping. Bootstrapping with random selection of rows and random selection of, and for each sample one decision tree will be built. For each sample one decision tree is, so in decision tree, in random forest, the sampling is the most critical. If somehow the algorithm is not able to create 1000 samples, until the sampling process is complete, tree building process will not start. Until step 2 is complete, step 3 will not be initiated. If some problem arises in step 2 because of memory problems or memory size error or something, if you don't have enough memory to create samples, then the algorithm will fail. So in the whole process of random forest, this bootstrap sampling is the most important aspect. Step 3 will start. Step 2 successfully decision tree sample is independent. Since each sample is independent, parallel building of trees is possible. Depending upon the number of cores on your CPU, that many trees will be built parallelly. Parallel building of trees is possible because each sample is independent. There is no relationship between one sample and the other sample. So each sample is considered as independent sample. So one decision tree is built for one. Full decision tree is built. Exactly like a decision tree equivalent to a single tree model and information gain. So just like your normal decision tree, a single tree is built for every sample using the similar methodologies. The Gini method or entropy and default is Gini. Default is Gini. Same just like how you build your normal decision tree. Similarly, for one sample, one decision tree is built. The tree building process is same as a single tree. For one sample, one decision tree is also done for each tree, and all predictions of trees. Step 5, if it is a classification problem, if it is a classification model, majority voting is done, and if it is regression model, so you will get different for one observation because it comes in multiple trees. Say Observation 20 came in 100 decision trees. 60 decision trees predicted it as yes. 40 decision trees predicted it as no. Prediction will be yes. Majority voting. Observe in regression, all the prediction values will be taken and the average will be calculated. And average will be the final prediction. So this is what happens in random forest. Random forest is a multi-tree model where you can build hundreds and thousands of trees. That many you can specify. Now, how many trees to specify? There is no fixed formula. There is no fixed formula to decide how many trees to be specified. Now, what we generally do is we randomly give a value of trees and then we build a model and then we plot the error. If the error becomes a straight line, the point at which it is becoming straight line, that many number of trees you can finalize as your final number of trees. If the error line is still not in a straight line, then we increase the number of trees. Then we'll plot the error again, and then we'll see a what you call elbow plot. Error plot, once it becomes straight line, the point at which becoming it, but means straight line means there is no change. The error is not changing after that point of time. Despite if you give many trees, there is no point because the error is not. Now the error plot, we won't get it in Python. We generally get the error plot in R very easily. So what we generally do is we do the final model building in R and then come up with the exact number of trees and then we implement the model in Python with that many number of trees. So that is one method. Or you can use grid search methods where we randomly give different values for trees and it will build that many tree models and then you can choose the best fit tree model that has the least RMSE and high accuracy. That is what we can do. So there is no fixed formula for finding how many trees exactly need to be built. So we randomly come up with a number, choose a number of trees, then we build it. Then we build one more model with more number of trees, one with less number of trees. Then we will compare the metrics and whichever is having the good performance, that many trees we will. So that you need to understand. In random forest, we have to specify the number of trees. By default, I think it is by default is 100. Criterion is Gini. Max depth is none. Max, which is his square root of number of variables. Bootstrap is true. Error graph for random tree, random forest will what you call it as. So this is how you will get the plot. Out of bag error, OOB error. This is a regression tree, RMSE. And you can see here number of trees on x-axis, the error on the y-axis. You will get a line. So basically, if you see here, after 300 trees, it is becoming a. So beyond 300 trees, if you give, it's of no use. So we can restrict the trees below to 300 number of trees. So this is the plot which we get in R. In Python also, they have said they will include it. Precision path, get params, predict log, predict score. They have not yet implemented. OOB errors for random forest. Yes. So it is still in testing mode. When you have this like this, it is still in the testing mode. This is the code to plot the errors. He is plotting the error for three methods: square root of number of variables, log of number of variables, and if you give none, that means include all variables for every sample. So these are the number of tree-based metrics. See number of trees on x-axis, the error on. So maybe in the next version we will get this model. This is still on testing only. You can see here it is in testing mode only. That will take a lot of time to build the models. The time. See, the problem with random forest is time. Computing time is required. Very large amount of time is required for large scale data. And if you have more than 1 lakh observations, you will not have enough memory to. So the problem will come is insufficient memory will be another issue. Your RAM size will also not be enough. So sampling is a big problem in. So we expect this OOB plot coming in the next version. So it is in trial method, experimental mode. The others who created the code and all, they are given their Gmail IDs and all. So once it is tested properly and then when it is ready, they will integrate into sklearn as a function, random values. Yes. For trees, we go for R and build the same model in R, and then we'll come up with the trees, and then you use that many trees as your final trees. See, that problem will come once it goes to production. The production guy says, give me the specific number of trees so that they can save the computing power. That time you have to do it. So the algorithm is, so random forest is for both regression and all the features, variable importance. It was initially developed to overcome the OR fitting problem in decision tree. Random forest is developed to overcome the OR fitting problem in decision tree. The reason why it was developed was to overcome the overfitting problem in decision tree. The multi-tree model is developed. Works. This is also a non-parametric algorithm. Random forest fundamentally is bootstrap aggregation. Fundamentally is bootstrap aggregating. Only disadvantage is it requires large scale computing power. That is the biggest disadvantage, which is computing power. So you can take your break. We'll meet after 15 minutes. They are different models. Yeah? They are completely different models, independent. There is no relationship between each of those models. That is a single tree model.
Okay.
That is a completely different model. Ensemble methods are completely different. There is no interlinking with them. They are different set of models.
So last was taught decision tree classification. Regression also.
Yeah, we have done it now. Car Deco.
Yeah.
We have done it on Car Deco. They are completely different models. From decision tree is one model, random forest is another model, gradient boosting is another model, neural network support vector. They are different models. They are algorithms. They are completely different. They are completely different. They are not same. The methodology might be some closeness of methodology will be there, but they are completely different algorithms. In terms of performance, in terms of computation, they are completely different models and algorithms. So after decision tree, we build random forest. Next, higher level model. So for this data, we are going to build the random forest, sklearn dot ensemble random forest classifier. RF is equal to random forest classifier and underscore estimators is equal to. So it first creates 5,000 samples, then it will start building the 5,000 actual decision trees. And then aggregation of all the outputs and then majority voting will be done for final prediction. So RF model dot score X comma Y 99.74, 79.15 cross validation score. No. I think on money Bajaj markets or somewhere, the amount is showing very less. No, in that they are also partnered with that Bajaj thing, right? Bajaj markets or something. Is it on Apple? Because I use iPhone. iOS app is there. iOS app is there because I use iPhone. Okay, what is this app name? Okay. Yeah, I've just sent it. Okay. See, without max depth, what was the performance of decision tree? 80 and 99.74. They are better compared to decision tree, right? So we can increase the estimators also. You can do it with 10,000 trees with max depth, with lot of pruning can be done in. So the amount of model stability you will get in random forest is better. It depends on data also. As we work on different data sets, you will see the difference. That is a very, very rare scenario. That's a very, very rare scenario. Most of the times, random forest has a better performance than decision tree. Who will pay for the computing? These algorithms require computing power. On cloud, computing is 29,000 rupees per 1 hour. So who will pay for the computing?
We need to boost it.
To convince them that if you use random forest and computing power, you need to give a business justification. Otherwise, why would client do it? ROI has to be shown to him. You can't jump to straight away to say XGB requires a lot of computing power. Random forest requires computing power. Gradient boosting from now onwards, all the algorithms which you are going to speak, except for support vector or naive Bayes and KNN. These three algorithms are less computing power. But if you are looking at random forest, gradient boosting, XGBoost and neural networks, lot of computing power is required. We don't need all the time high accuracy. In real time, getting an accuracy of 70 to 80% is big because real time data has lot of challenges. In competitions, you might get 95% accuracy, 96% accuracy, but in real time data science, getting an 80% or 85% accuracy itself is a very big challenge. And retaining it on different subsets of data or maintaining it is a problem. So we don't go for high what you call accuracy models. We go for a stable accuracy models. Models that are stable in production. You have to go for models that are stable in production. Forget your clients. No recruiter will recruit you if you say you will be directly using random forest. That is why a lot of resumes don't get shortlisted. Because they get a professor, they don't do basic exploratory data analysis, they don't do anything hypothesis testing, they don't build a baseline model to compare. Nothing is done. They straight away jump to XGBoost and they say it happened with PJ 17, 16, 15. They straight away jumped to copy the code from somebody and jumped it and they said their resumes till now some of them are not shortlisted. And when we asked the client, they said same thing. They are giving models which cannot be implemented in real time. XGBoost is not used in real time data science at all. XGBoost is not viable in real time data science. Random forest is viable based on the data you are dealing with. Neural networks not viable because there is a lot of fine tuning to be done to that model, and it also requires computing power. Now, if the computer, some companies are interested in computing, who can invest in computing power, they can use advanced models. Otherwise, they will use base models like decision tree, random logistic regression, and linear regression. Like I told you, disadvantage is computing power. You need a lot of computing power. So computing power is costly. Otherwise, if he has to install server, one server costs to 3 lakhs, and the power cost, AC cost, and all put together, it will come to 6-7 lakhs. So who will invest that much of money? Right, you can't, server is a very costly investment, right? Computing is costly investment. So baseline models are what we use in real-time data science, which requires less computing power. The outputs are easy to understand. And you can also fine tune those models very easy because you understand the output. In random forest, it's very difficult to understand the output. You have output of 5,000 trees here. Experienced guy like me can go find out which tree, what, and all we can do it. But how will you analyze 5,000 trees output? Or neural network gives you lots of output. We call neural network as black box model. Black box models are those models whose output you can't understand. White box models are those models whose output you can understand. White box models are linear regression, decision tree, and logistic regression. Because you understand the equation, you understand the decision tree. To some extent, random forest and gradient boosting because you can extract the tree. But in case of neural networks, you will get lots of output, lots of metrics calculations are there. It's very difficult to understand the output, so we call it as black box model. So you have to understand the output also needs to be understood. It's not simple implementation. You need to explain the output, the mechanism, everything to the client in detail. If you can't do it, the client will never approve the model. Explaining him the output, what is this means, and all the metrics, the equations, and all very easy in linear regression and logistic regression. And a tree is very simple to interpret for anybody in decision tree, but not so in other case models. So always we have to follow the hierarchical of model building. You can't jump. The advanced models are all computing costly, very, very costly to the computing. So most of it we do it in competitions only. XGBoost is used. It is not used in real-time data science because it requires a lot of parameter tuning, less computationally intensive. They will look for basic models only. So did they mention any algorithm here? Algorithms will not be mentioned. Because nobody knows which algorithm will be used. Python, R, Tableau, machine learning, SQL. So nowhere they will specify algorithms. It will be broad-based, machine learning, statistical analysis, mathematics, Python, R, SAS, or Stata, the tools. That's all. Machine learning is what they will say because we don't know which algorithm will work on what data. So they can't specify that, we need only this set of profiles with this algorithm knowledge. Now, during interview process, they will tell you what existing they are using. And they will ask you, do you have understanding of these algorithms? During the interview process, they will say, we are already having some models already being used in our thing. So they will ask you that cluster analysis or linear regression analysis or decision tree. If it is natural language processing, they have their own specific algorithms. If it is image processing, different algorithms will be there, base algorithms will be there. So for every field, there will be some baseline algorithms. And most of the times we use baseline algorithms only in real-time data set. Advanced algorithms which are developed daily, which requires a lot of computing power, are avoided in data sets. That you have to keep in mind. It has to be done with simplistic thing. Another thing is you have to have simplistic option. That means whatever you do has to be easily understood by your client also, right? Some people write complex functions for a simple task. That is not required. When a predefined function is available, use it. You don't need to run complex codes and all those things and all. Use functions. Sometimes the functions will be vary. In SAS, you might need to write a function, DEF function to run the particular task. But in Python, you already have a predefined function. You will use that. It happens same thing with the Capgemini guys when they're converting SAS code to PySpark. Already predefined functions are available for that particular set of code. So no coding required because the functions are predefined in Spark, Python Spark. You will implement them. And then your code will become easy to understand. See, the biggest challenge is the pre-processing. Model building is not a problem at all. Data cleaning is what takes months and days to clean the data. That is the biggest challenge. Model building is simple, 5%, 2 minutes. you'll get the output, the values and all. But bringing the data to that stage is the challenge. And then how you do that data process, that you have to understand. Now, the other day, one student called up saying that I got 90 lakh rows of data, what should I do? You can't do data pre-processing on 90 lakh. So subsample, use random sampling, make it a 10 lakh data set or a less than 10 lakh data set, then start working on it. He said, I am not able to do anything with 90 lakh rows. You can't do anything with 90 lakh rows. Excel is not there. No? It's what you call it is it is not even an Excel file because Excel has only 10 lakh rows, right? Or it can be a Parquet file. Parquet is even for larger data. When you have 90 lakh files, you get Parquets. Parquet files will be generated. Now, Parquet files you can read in Python directly and you can see the shape. He imported the Parquet file and he saw the shape as 86 lakh or something like. And I said, you can't do anything with that. You have to subsample it. Reduce, randomly pick some sample, reduce it to lesser number of rows, and then start working on that data. Otherwise, Python can't open 96 lakh file. How can it work? So that is how we have to work upon this. You have to sampling. You have to tell the client it's not possible to work on such large data. Then if you insist, then you ask him for an AWS computing power processor and use Python on AWS or Azure or Google Cloud. Because there the processes are very large and the computing power you pay per hour, you can rent as many processors as you need and then you can work on 80 lakh data set. And BigQuery is already there given by Google, which is compatible with Python, or BigQuery is Google's product for large scale data, petabytes of data. When you have to do, BigQuery is provided by Google. Now, BigQuery also works with, then again, if the client is okay with it, then go with billing and all. So these things you need to understand, the sample sizes, how to clean it, how to restructure it, how to reformat it. All those things you need to understand, then only you can build a model. Model building is a very small task in the data science process, but bringing the data to that structure is the problem. So implement random forest regressor on car data with 3000 trees. Implement the random forest regressor on car data. So from sklearn.ensemble random forest regressor. RF is equal to random forest regressor n underscore estimators is equal to 3000, 53,498. We have worked on Kaggle data, advanced house price. So if you remember on the Kaggle data, we built a linear regression model and we submitted into competition site. See, when we submitted earlier, 0.3559 is what we got, right? 0.3559 is what we got as metric as per the competition, which was done on multiple linear regression, right? Now, on the same data from sklearn.tree, decision tree is equal to decision tree regressor, tree model is equal to tree.fit x comma tree model dot score x comma y. See, we got an R square of 1. R square of 1. Tree test predict is equal to tree model dot predict. I predicted on the test data. Test data don't have the dependent variable. We are predicting it, right? PD dot data frame tree test predict dot to underscore CSV tree dot CSV. So I have opened the sample submission. We have the decision tree predictions, Control C, 0.20. How drastically it changed from 0.35 to 0. Now, for the same, we'll do random forest. RF is equal to random forest regressor n underscore estimator. RF model is equal to RF dot fit x comma y. Which one? Random forest. This one, memory error. So, which model, which data? Reduce the trees to 1000 or 500. What is the memory size? Memory error, what GB it is giving? Go to the end. In the end, it will give you somewhere around 8 GB or something. So it's better to reduce the trees to 500. What is your RAM? So 4 GB, it's just difficult. 4 GB, always go with 500 trees. See, 9819 is R square. RF test predict is equal to RF model dot predict house test DF. PD dot data frame RF test predict 2 underscore CSV RF dot CSV RF 5000 for improvement 0.35 to 0.20. Now random forest is 0.14. Root mean square algorithm. Logarithmic. So it will convert the logs, both log, whatever you are submitting, it is converted into log values. That's what it's in RMSE. Between the logarithm of the predicted values, less space. Because people keep on submitting, no? Then they need to save the space. If the larger values are there, lakhs of values are there, no? House prices are in lakhs. If people are submitting in lakhs, see, the sale price is lakhs, right? They have to do it logarithmic, they have to save it. There's a lot of people use it and they want to save the memory space and all. They are whatever you are submitting, they convert it into logs. For them also storage is cost, right? And look at the people, how many people are participating? 4,577 people are submitting. Top 40%, 1826 score rank. So if you look at the rank, I think I will use gradient boosting. That's why we got a slightly better model. Top ranker.
Why he is in top, like, he got a room mixture, we have to zero.
See that zero guys, what happened is, some people what they randomly see, test data is nothing but data taken from the train data only. People, the first competition data who was there, now they removed those row matchings and all. Now they removed those row matchings and all. When the competition started 5 years back, the first data set is where we had the row numbers of the test data. So we know the actual values. So these people who got zero, they are using that, they are submitting the same values. When you submit the same values, obviously you'll get zero. So that is what happened. After what happened is 3 years back, they removed the old data, restructured everything, they removed the row numbers from test data. But people who participated in the first competition, who had the complete data access, they know the actual values and they are submitting the actual values. Actually, in GitHub also you'll find the actual values. But what is the point? In recruiters, will also ask you to show the CSV file of your predictions. It happened with one of their person for the same Kaggle. They said upload your predictions also. You said you build these models. You upload the predicted CSV files also into GitHub. Let us see what predictions you have done or not. Same thing. Some recruiters who know these things, they're very particular. Technical time, they'll ask you. They'll say, open your CSV file, which you have made predictions of different models, then compare them. That also they will ask you to do. Like one guy asked all the Kaggle predictions to be posted into an Excel sheet, predicted values, and do a comparative analysis. Calculate the mean, standard deviation for each of the prediction, plot them into a bar plot. That also they'll do. So getting zero is different. Now you will find a lot of discussions. If you click on data code, see top 6%. This guy gains is in top 6%. That means top 400 or so what he is using. So here XGB, LGB, SVR, lasso ridge, stacking regressor. He is using stacking regressor. Exploratory data analysis and all he has done. He built all the models from baseline model to the advanced models. So he created a stacked model. So now stacking is process of taking weighted. We got predictions. Now I have done 3 predictions: regression, decision tree, and random forest. I got 3 predictions for observation 1. I'll take 30% of this, 20% of regression value, 30% of the decision tree value, 50% of the random forest value. Create a new weighted prediction. 20, 30, 50, you will get a new weighted prediction, right? And then you will use that for submitting. That is called stacking. So you will take all the model predictions, assign weights to each of them, and then you will get a new prediction and you copy that into sample submission and submit it, which will be better model. So this guy is doing the same thing. He built all the models, random forest, light GBM, XGB, GBM, SVR also. And then he did the stacked regressor. Yes, stacked regressor, now there is a predefined function in Python. So you have to give the estimators, okay? List of models is the example code. So here he is building the ridge regression, linear support vector regression, 2 models. Reg stack estimators is equal to estimators. Final estimator to compare is random forest regressor. Baseline, you have to have some, but this is a very small data. Diabetes data is a very small data, 10 trees he has done. And then he has done the stacking model. So you can define all the models, final estimator. If you don't specify, default is ridge. Otherwise, you have to specify the final estimator. So a regressor which will be used to estimate, combine the base estimators, the default regressor is this. So now stacking regressor is available in, so the output of individual estimator, final prediction, time consuming process. So we can test stacking regressor also. 3rd floor lo unnara? Kadamma, pakka building. K Feclat, HDFC, K Feclat and undi kada, aa building. HDFC, aa building lo 3rd floor. Car kaadu, HDFC kada, 2nd floor, 3rd floor kavali. Ematicus learning, 3rd floor. So stacking predictions is what he has done, right? So he got 6%, where he built all the models and he gave the stack regressor and his final predictions. You can upload it into this. But without doing pre-processing, you can't jump to models, right? See how much of pre-processing he has done. So this is the right method. EDA, exploratory data analysis of numeric variables, box plots of numeric variables, violin plots. See, you have to do EDA. Then only you'll go into model building. Never ever jump to model building directly. And don't jump to direct models, advanced models directly. You have to build baseline models also. And slowly we one by one model. And then finally you can use tracking regressor if you want with a baseline model. And then it will be doing. So 1.2, he's not also going for the 0%, right? If you are in top 6%, the more focus by the recruiters will be on the methodology you followed, how you clean the data, how you process the data, what assumptions you made about the data, what is your understanding of the data. That is more important, not the accuracy. So this has to be done. You have to explain. If you're using box plots, why did you use box plots? They are univariate plots, can be done only on numeric. One student told the recruiter, it seems box plots can be done on categorical data. So that is the level of, that is absolutely wrong, right? Univariate plot can be done only on numeric. So you need to have that understanding. You should be able to explain to them. I analyze this data using these plots. This gave me outliers are there. So I have done this scaling. Then I have implemented the model with scaling, without scaling. Then we found out this difference. All these things have to be explained. Otherwise, say 2 days ago, generally, I ask people to do a lot of EDA on this thing. See, this guy has done EDA and feature selection, correlation analysis. So a simple notebook of EDA will also get you a job rather than a copied notebook of models. Don't copy anything which you can't explain to the recruiters. And once you lose an opportunity, you will not get an opportunity back for 1 year. That is the problem. And we have seen people who copy pasted the codes or who copied from other notebooks. They didn't clear the interviews till now. They are struggling to find. So make sure you understand. See, if you are not comfortable with random forest, don't tell the recruiter you know random forest. You tell them, yeah, we were taught. But you are confidently explaining linear regression, that is enough. Explain to him what is logistic regression. That's enough. But you tell them, we train you in neural networks also. We have been trained in everything, but I can confidently explain this algorithm. They will only tell you, you choose what algorithm you want and explain it to me. Right from the equation, assumptions, the interpretation of output, everything you should explain it to me. If you do it properly, you will get a job 100%. That is what they will say. And whenever you do, explain the base models only. Don't try to attempt the advanced models. You tell them, I know how to process the data, how to execute them, how to. We need to understand the explainability is also there. Your language skill, how easily you can explain, you write down. Right? So it's your choice, which model to explain, how to do it, it's in your hands. So we get every feedback from the interviewer, recruiter, and they show it to me. The recruiter for this candidate has said this. Most things I understand is they are not able to explain the basic algorithms like linear regression or logistic regression. Or if it is a specific profile, they were not able to explain like image processing. What is convolution neural network? That is a baseline algorithm in image processing, where I have explained them the calculations, everything we have given the notes. They were not able to explain it. They said they can't explain the CNN process. Okay, it's a complex algorithm. But if you want high pay jobs, you have to be able to explain and understand those complex algorithms. They were ready to pay 8 lakhs on image processing data. But they are looking people who are good in CNN. They said we are implementing YOLO. YOLO is a very advanced algorithm in image processing, developed by Google. YOLO version 5. Which came last year. It can process at a single point of time million images. That is the capability of that algorithm. So, but not everybody can afford YOLO. CNN can be run on your normal Google Collaboratory or Kaggle. So they will take that. So understand the process, understand the methodology. EDA is more important, exploratory data analysis, data pre-processing than model building. And nobody goes for 100% accuracy or 100% this thing. You have to have certain amount of what you call a notebook. Even if you build a notebook with linear regression, that's enough. You will get in top 50%. The problem with this data is a lot of people can't even process the data and submit it, Kaggle, because it requires a lot of pre-processing steps, right? We have spent one whole session on Kaggle pre-processing. That because I know how to do it, so I could explain it for you. But if you're doing first time, how many days you will take to understand how to process it and how many times you will make a mistake? So I will give you a real-time data. Then you will understand how many days it takes to clean it up. I will not tell anything. Maybe after completion of next week or the other week, I'll give you a live data. You have to clean it First is forget model building. You have to clean it. Cleaning itself will take lot of functions. Like you remember dressify data, why I gave dressify data? Very, very minute things also will cause problem. Remember the dressify data? Small things also will create problem in your. So you should have that eye for understanding what is that thing where the problem lies. And then you have to target that. If you are unable to identify the problem, your notebook will keep on generating errors. So that is the issue. So make sure EDA and pre-processing, you focus a lot. Recruiters will also ask you a lot of questions on those things. Very few questions you will be asked on model building. That too, they will only tell you to choose. Okay, explain me an algorithm. But they won't ask you. They will say, what is the purpose of box plot? In EDA and hypothesis testing, they will ask you specific questions. When do you use t-test? What is the null hypothesis of t-test? What is the alternate hypothesis of t-test? How will you reject or fail to reject? What is standard scalar? What is the formula of standard scalar? There you get specific questions. In models, they will say, explain me a model which you know. That is what happens in interviews for model questions. But when you look at EDA pre-processing, you will get very, very specific. Here you need to have those understanding. What is the importance of mean? What is the importance of standard deviation? So how will you relate mean and standard deviation? How do you interpret them? These are the questions they ask you. Recently, last week, one guy went to interpret. Very basic statistics questions were asked to him. He could not answer those questions also. That's what the feedback came. Lack of basic statistical knowledge. So we can't proceed to the higher levels. He was not able to answer the basic statistics questions itself. So they didn't progress the interview to the next level. So yes, you can refer to it. That is where your GitHub will help you. That is where it will help you. You can, if you have access to system, if it is a video thing, you can immediately open your GitHub thing and you can relate to it and show it to him. See, this is what I have done. This is where, and that's why I ask people to write the notes also there in GitHub itself. So you'll know what to explain, right? When you're uploading the notebook, that's why I put the hashtag and write it notes. I can put it in Markdown and I can type it notes and all. But why I put it like hashtag and write it, it will also help you to refer to that notes related to that particular cell. Now, if I write it in Markdown cell, a fundamental question will come. Is this note belong to the top cell or is this note belong to the bottom cell? It happened with me. It happened in one of the corporate trainings when I was using Markdown cell. That guys were asking, sir, these notes relate to the top cell or these notes relate to the bottom cell. Now, what should I do? That's what happens now in Markdown. Markdown, you will just, I can write the notes, type the notes, comments, everything in the Markdown. But can you relate it? That happens. That is why I write the thing in the same cell, so that that question does not arise. A lot of people ask me, sir, why don't you use Markdown? Because again, saying that if I write it in the same cell, that means you'll understand that notes belong to the, for your benefit only, I am doing it. So that's happened with me, so I am telling you guys. So you should, you also use the same thing. Write hashtag, write notes, interpretation there only, open it, explain it. And they will not object to it. They will never object to it. They will look at it. Then all your discussion will go to that particular GitHub notebook only. Why use this? Why you have used that? Then your chances of recruitment will be. Otherwise, they will ask you some statistic question, which I may also not be able to answer. Because statistics is ocean. Something question they can ask, right? He can ask anything in statistics. Keep your GitHub's profile ready. Keep your analysis ready. Focus on that part. Let us discuss this part. That way, your chances are high. Otherwise, some question comes which I may also not able to answer. Okay. So please maintain analysis also in the GitHub notebooks which are uploading. Kaggle, I would suggest this is a very interesting notebook. Add some EDA, do some visualizations, box plots of variables, numeric variables and all, and then upload it into your GitHub profile. And for every submission, you also put your score. It gives you top 40%, top 50%. If you scroll on top of it, it will tell you top 40%, top 30%, top. So score and your ranking in the notebook you mentioned. And how it improved, you will understand. Now you understood the hierarchy of algorithms, right? Morning you're asking, right? Somebody how to decide what. Now you understood, right? MLR gives you 1. Next level is decision tree. Next level is, now if next class we will discuss gradient boosting. That will marginally give you 0.14 we got in random forest. 0.1372 something you will get in gradient boosting, marginally a little bit better. So that's how you have to go by model, right? So start working on the Kaggle data, add some EDA. You can get ideas from the notebooks which are available here. Do some plottings, right? Bar charts, box plots, couple of hypothesis tests, t-tests and all those things. And then you can upload this notebook. And also whatever scores you are getting for each submission, put it there. The more exploratory data analysis you do, the more understanding you have. Second thing is, if you do EDA, you will perfect your Python skills. You're getting it right. You do box plot 5 times, 6 times, 7 times, and you analyze it. You will learn a lot. Not 5, at least 3 times you do, 2 times you do, you'll understand it, right? You'll remember the formulas, you'll understand it. If you are properly doing it, you create a lot of histograms, then you understand the concept of skewness will be there, right? You do a lot of scatter plots to understand relationship between variables. You do correlation plots. So it will perfect your Python skills. Second, it will also improve your interpretation skills, which are required for your jobs. That is why we need to do. Simply plotting is not enough. You have to write the interpretations also. Positive skewness, negative skewness, correlation is there or not, linear relationship is there or not. So everything they will write, everything they will do. So a lot of see, this also 5 days ago, some guy did EDA. I'm telling you, EDA gets you more jobs than advanced model building. All this is for people who are learning data science. See, he is writing everything, interpretation and analysis. For every variable, he has done it. So he has done it detailed, maybe part of the assignment given in his college or something like that. So you can see here, data pre-processing, label encoding. He's still working on this data. So if you are doing these visualizations, your Python skills will improve. Like how to add sub-arguments, you can plot histograms of multiple variables using a for loop, like frequency counts we did, right? So use that. And then you have any doubts, you can ask me for those workbooks and all. But so the intense competition, this is what distinguishes. Now, compared to a simple notebook to this notebook, what will recruiter prefer? This notebook you will prefer, right? Because this guy used advanced graphics, multiple things and all. His knowledge is better than a simple notebook guy. So that is a differentiating factor. So you have to, because there are a lot of people learning data science. So you have to differentiate yourself. How do you differentiate? Knowledge of Python, knowledge of statistics, knowledge of SQL, knowledge of R. In SQL also, don't write simple queries. Do multiple joins, understand, write complex queries, real-time data and all that. Everybody can write the basic queries. Select star from all those things, but look at the joins where you have to join 4 or 5 tables, then you have to group based on a variable, then you have to do sending order, that sort of things you have to. Sometimes you have to create temporary views in SQL, temporary tables have to be created, and then you have to, that sort of queries will get you job, not the basic. So please work on, look at these EDA things, whichever you like, you can refer to them and try to work on your EDA skills also, okay? And then model building skills, hypothesis testing, all these things are advanced. If you have advanced knowledge, you will get higher pay. If you don't have advanced knowledge, they will not pay you. All right. So by next week, I expect all of you to have GitHub profile ready with the Kegel House Prize thing. Add some cells to this and do analysis and you can upload it. No issues at all. So interviews, they'll ask you specific models. In job description, they will not give you. They will simply say machine learning only. What specific algorithm they are looking at, they will ask in interview. Most of the time, it will be baseline models only, not the advanced models.
So in one of the articles job they said
Yeah.
like what kind of
Yeah, that's what. No, when to use t-test, when to use ANOVA, when to use chi-square test, what is null hypothesis of t-test, what is, how will you interpret the output of a t-test, how will you reject or fail to reject the null hypothesis, what is 0.05. First, they will send you the data set and ask you to do some hypothesis test. They will not specify also what test. You have to understand the variables and you have to do it. Or you can simply say null is always no significant difference, alternate is significant difference. Simple. Null is always no significant difference. Alternate is always significant difference. Difference in means is not significant in null. Difference in means is significant in. So I have seen people, at least you will get 3 or 4 hypothesis test questioning. If you cross the basic descriptive, basic statistics questions, if you clear the basic statistic questions in interviews, you will definitely get hypothesis testing questions and then they will get the model building questions. But if you fail in the basic statistical questioning only, your interview will stop there only. That is what we are seeing in the recruiters. They are not progressing. They will, and the feedback is the basic statistics, he doesn't know, what will he know in the advanced. Same thing, descriptive statistics, univariate statistics, what are the dispersion measures, what is standard deviation, what is his interpretation. I will discuss now what is positive skewness, what is negative skewness. Formulas they will not ask, but if you tell them, that will give you more chance. They will not ask you, but if you tell the formula, that will add more weightage to your profile. So in the interviews, with the constant interviews, whoever is given, when they told the formulas, their recruitment chances are very high. So all the students who perfected the formulas, they are all placed. Like linear regression, X transpose X to the inverse to the matter. That guy is working with the WNS now, Bangalore, as data scientist, PJ70 batch. So it's up to you. In the PJ same 17 batch, one guy is working for 2.4 lakhs SQL profile. He is not that good in ML and stats. He is working with 2.4 lakhs in SQL profile. So some small company in Raja Mindspace. You want the higher salaries? If you don't want, I'm happy with the base knowledge, you can go with SQL only. You'll get a job at 2.4 lakhs, or that is maximum they're paying for SQL. SQL plus Python plus R. So you have to perfect all those things. See, whatever you know it thoroughly. That is the fundamental here, because we can't completely know complete machine learning. You are not expected to know complete Python because it's big ocean, right? But whatever you know it 100%. Whatever you use in pandas, whatever you use in NumPy, you should explain them. When do I use group by? What is the importance of group by? When do I use what you call concatenations? You should explain what is concatenation, what is group by. Because pandas itself has 18,000 functions. NumPy has even more than that. We can't remember all of them, right? Yeah. So in one interview, they ask you what is group by. You have used group by. What does it do in the backend? It will split the data into two and calculate the relevant data frames metric what you are specifying. That is what group by do, right? Split the data into 2 or 3, whatever levels it has. And then if you specify mean, it will calculate the mean of each of the sub data frame. That is how you have to explain. Now you have used group by, what does it give? It happened with one girl. Similarly, they asked question with what is the difference between a histogram and a bar plot? Histogram and bar plot both are same, right? Visually. But histogram is created on frequency distribution table. Bar plot is simply a frequency table. Bar plot is done on frequency table. Histogram is done on frequency distribution table. Frequency distribution table will have class interval, and whereas in a bar plot, we just have categorical and frequency. That is what they ask you. Difference between histogram and box plot. So you should be able to explain. There are two different concepts, right? Completely different. But visually both look same. If you look at the graph, both are bars only, right? You get both bars. What is the difference? But methodology is completely different. That is how they ask. What is multicollinearity? How do you identify multicollinearity in correlation analysis? So you get a very large correlation table. How do you interpret it? I told you, no, heat map. You have to tell them that you have 100 variables. You did a correlation for 100 variables. How will you interpret it? You say, I will do it using a heat map. That will solve all your problems, right? You can have any number of variables. Heat map will give you the thing. So that is what you have to do. These are the practical questions they asked. What is the importance of normal distribution in regression? So should dependent variable has normal distribution or independent variables have normal distribution? The interview person, the candidate told independent variables. Where normal distribution is more important in regression? Dependent variable, right? The assumption is dependent variable must be closer to, it is most important in the case of dependent variable, not in the case of, but if this fundamental assumption is not met, will you build a regression model? If the fundamental assumption of closeness to distribution, normal distribution is not there, will you build a regression model? Why not? You can do logarithmic transformation and you can build it, right? That's what the person told. If it fits onto the logarithmic transformation, then I will build a multiple linear regression model. If logarithmic transformation does not work, I will go into the advanced models like decision tree, which is non-parametric. That is how you have to explain to the recruiter. If I'll try to do logarithmic transformation, if it doesn't work, then I'll go into decision tree model, which is a non-parametric. This you should be able to explain in clear terms. They'll ask you, if the data is not suited for normal distribution, will you build regression model? This is the exact question was asked to the candidate. Out of 3, only one person could answer the question and she got placed. The other 2 simply said no. But what is the procedure? You will try logarithmic transformation. If it doesn't work, then we'll go to decision tree regression. Decision tree regression is a non-parametric algorithm. It will give a better output. That's why I'm asking you to understand the models, compare them, and then you have to answer these questions. Okay. So we'll end the session, and next class we'll meet. We'll do boosting, gradient boosting machine, GBMs. The other type of multi-tree model, ensemble method. And this bootstrapping is also common interview question. What is bootstrapping, aggregating, and where do you use it? Or they will say, what is bagging? Where do you use it? Bagging is used in random forest. It's a sampling method. It is a sampling method where observations will repeat in multiple. So make sure you study these things properly.